We had done couple of forces. Then we have a torque of a couple. We'll discuss that. And from there onwards, we'll do the questions. So what is a torque of a couple? Remember that we have two forces here, and that is turning the object. What is the basic property? Both the forces are equal in magnitude. One force is down, the other force is up. That is, they are equal in magnitude and opposite in direction. So, such forces form a couple, but a third condition is also very important, and not along the same line. Two forces form a couple if they are equal in magnitude, opposite in direction, and not along the same line. Let us find the torque of this couple. If you observe, if the pivot can be placed at any point, if the pivot is placed at the center, the force on the right hand side will have a distance d by 2. The force on the left hand side will have a distance d by 2. So your total turning effect or resultant moment will be, both of them are clockwise. So F into d by 2 plus F into d by 2. So it becomes F into d. But this is the definition of torque of a couple. F into d means one of the force and perpendicular distance between the two forces. That means you don't have to find individual moments, just multiply one of the force and the perpendicular distance between the two forces, and you get the value of torque of the couple or resultant moment. So couple are two forces equal in magnitude, opposite in direction, and not along the same line, whereas torque is the resultant moment, and we just find torque by multiplying one of the force and perpendicular distance between the two forces. You must be able to identify the torque. You must be able to identify the couple. Definitions of both torque of a couple and couple of forces is very important. It may ask you about it, and then use the formula. Now here we have two forces F1 and F2. They are equal in magnitude. Do they form a couple? Yes. And what is their perpendicular distance? It is R1 plus R2. Now these forces are equal. That is why it becomes a torque. And the torque will be one of the force multiplied by perpendicular distance between the two forces. Okay. We have two forces F. Ranch hai koi ye, and we are turning it. What is it? Is it a couple? The two forces are equal and opposite. So it is a couple. And the torque will be F into 2D. Again, we have two forces equal in magnitude, opposite in direction. But interestingly, they are both are not creating the same direction of turning effect. Will it still be a couple? Yes, it is a couple because it fulfills all the requirement. They are equal in magnitude, opposite in direction, and not along the same direction, in the same line. So what should be their torque? F into x2 will be a greater turning effect, so we can subtract F into x2 minus F into x1. If I take F common, it is x2 minus x1, and x2 minus x1 is the distance between the two forces. So it also has the same formula for torque of the couple. Again, we have one force is downward, the other force is upwards, equal and opposite. So it will be F into L. Is this a couple? No, it is not. So therefore, torque is also 0 in this case, because These forces are equal to opposite and they will cancel out each other and they will create no turning effect. Okay, जी. Next देखिएगा. Now, are these forces a couple? 8 newtons and 8 newtons, both of them are equal and they are opposite. So they form a couple in this case. In this case, how to find the torque? Distance is 0.6, but it is not perpendicular to the forces. So we will find out a perpendicular component of these forces, which is 8 sine 60 multiply by 0.6 and you'll get the torque of the couple. So you have to find a perpendicular component of the force and then multiply by the perpendicular distance and you'll get the answer. Again, we have a torque of a couple. Two forces F are acting here with a distance of 1.2 meters and that is being to stop the turning of the disc. The disc is being pulled by a force of 900 newtons. So this will create a torque 900 into 0.2. That will be balanced by the torque of F. So anti-clockwise movement will be equal to clockwise movement F into 1.2 will be equal to 900 into 0.2. Simplify that and from there you get the value of F. So you have to understand the question and then answer it according to the requirement. So these are some of the examples of torque. Now we go back to the questions of this chapter. Let's see how to solve the questions. Just in this case, it says define center of gravity. It is a point where whole weight of the object appears to act for any orientation. Appears to act. Where the whole weight of the object appears to act. Now we have a similar question that we have a rod which is supported by a string. The tension in the string. Now this time tension in the string is given to us as 30 newtons. And this time the mass is not given to us, which is attached at the end. They ask us what is the vertical component of tension. So tension is 30 newtons. It will have two components, vertical and horizontal. If this angle is 50 degrees, this angle will also be 50 degrees and the vertical component will be 30 sine 50. Horizontal will be 30 cos 50 in this case. So vertical component is 30 sine 50. Then they ask us to state principle of moment. Proper statement. If a body is in equilibrium, sum of anti-clockwise moments is equal to sum of clockwise moments about any point as pivot. Definitions are very important. So this is how you define that. And they ask us what is the weight of the object O. 8.5 will create clockwise movement, mass will create clockwise movement, and only the anti-clockwise movement is to be calculated by T vertical because that is perpendicular to the distance. So anti-clockwise movement must be equal to clockwise movement. T vertical is at 1.2 distance, 8.5 is at the midpoint because it is the weight of the object. Mass is also at 1.2 meters. So simplify that and you get the value of W as 90 newtons. How to find mass from weight? W is equal to mg. M is equal to W over G. And you get the answer. Now, if you observe upward forces is not equal to downward forces, and similarly, the horizontal component of tension is not balanced. They ask us to use the concept of equilibrium to explain why a force must act on the rod at A. Now, that force was not considered in moments. Why? Because A is the pivot, and if any force is acting as the pivot, it will have no moment. So, in the first case, we didn't consider it. But since the forces are not balanced, so we have to consider that force which is acting at A so that vertical and horizontal forces are balanced. The sum of vertical forces is not zero. Similarly, there is no force to balance the horizontal component of tension. Therefore, there must be a force acting at the point pivot to balance the vertical and horizontal forces. So this is a very typical answer why there must be a force acting in the pivot to balance the object. Okay, let's see another question. A similar question. In this case, the center of gravity is not at the center, it is at a distance AC from the pivot. We have force F acting at the pivot, we have tension, and we have weight. What is center of gravity? It's a point where whole weight of the object appears to act for any orientation. Equilibrium. Resultant force in any direction should be equal to zero. Pehli condition. Number two, resultant moment about any point at pivot as pivot is equal to zero. So both conditions should be satisfied for equilibrium of an object. Whenever they ask you what is equilibrium, you have to state these two conditions. Now they tell us that if we continue the force F, it will also intersect at point P, which is the intersection of W and T. Why? Why it is necessary for the object to be in equilibrium? All the three forces must intersect at a single point. Now remember that we had the condition that the object is in equilibrium, the resultant moment about any point as pivot must be equal to zero. If these three forces are passing from P and we take P as the pivot, in that case, resultant moment will become zero. That is why we say that all the three forces must be passing from the pivot. And pivot is our choice. We take the pivot as P, as the three forces are passing from P, so their respective moments will be zero and the resultant moment will also be zero. Now they ask us to resolve the horizontal forces. We have only two forces which have horizontal component. One of them is T cos beta and the other one is F cos alpha. F cos alpha is towards right, T cos beta is towards left, so they must be equal and opposite. Or if we add them, we should get the answer equal to zero. Similarly, for vertical forces, we have T sine beta, we have F sine alpha, and we have W in the opposite direction. So, we can say F sine alpha plus T sine beta is equal to W or minus W is equal to 0. Now we have to take the moments. W will have a clockwise moment and T sine beta will have anti-clockwise moment. They should be equal. So, T sine beta into AB should be equal to W into AC. Again, AC is given to us as 2 by 3 AB. So we can replace it here. AB and AB cancels out and we get an equation 3T sine beta is equal to W. Okay, here we have again the center of gravity definition. It's the same answer. where the whole weight of the object appears to act for any orientation. Now we have two Newton meters. It is supporting a wood XY. The length of the wood is given to you as 2.5. The weight of the wood is given to you as 950, and the weight of one of the Newton meter is given to you as 570, which is A. What is the weight? What is the force representing the Newton meter B? Remember that the object is in equilibrium, so upward forces must be equal to downward forces. Upward forces are FA and FB. Downward force is 950, and from there, FB comes out to be 380 newtons. Now they ask us to label the position of center of gravity. If you observe, the left side Newton meter has more force, the right side has less force. अगर दोनों की force equal होती, then the object's weight would be at the center. But now the force on A is greater, so weight should be closer to this Newton meter A, so it will be somewhere closer to A, not at the center. Some distance D from A. They have asked us to find distance of the weight from X. In such a case, we can take any point as pivot and simplify that to find the value of D, and that will give us the distance from A. That plus 0.4 will be your total distance from X. In such cases, generally, we take pivot at one of the unknown values, but we know both the values. In this case, I take pivot at A. So that the force of 570 will not be in the equation, only the force of 380 will be in the equation. 950 will create clockwise movement and 380 will create anti-clockwise movement. And from there, I can find the value of D. So we know the value of D. What's the distance from X? It is 0.68 plus 0.4, and you get the distance from the X as 1.08 meters. You can take any point as pivot. You can take A as a pivot, X as a pivot. It's all your choice. If you take X as a pivot, then you directly get the distance of 950 from X. But then you have to consider the moments of force meter A and the force meter B. Again, a similar question. We have a plank. The weight of the plank is 200 newtons, and a person is standing at a distance X from A. His weight is 880 newtons. They ask us that the sum of the forces Fa plus Fb is always constant. Because the object is in equilibrium, so upward forces will always be equal to downward forces. And upward forces is Fa and Fb, and downward forces are 880 and 200. So their sum will always be equal to 880 plus 200. So they will always be constant no matter where the man stands, because his weight will be vertically downwards. Now they have told us that the person is at a distance of 0.5 meter. This distance is 0.5 meter. So find the value of FB. FB. I take the pivot at A, 880 clockwise, 200 clockwise, and then F will be anti-clockwise. And from there, I can find out the value of FB, which comes out to be 188. Next part. They say if the person is at 0 centimeter FA is maximum. But as you move towards B, FA decreases. Remember, if you are close to one pivot, you will have all the force on that side. If you go to the other side of the pivot, other side of the plank, the force will be transported that side. So it will be a reverse graph like this. Initially, FB will be 0, minimum, FA is maximum. As FA decreases, FB increases and becomes maximum when FA is minimum. So it's a reverse graph that we will get in this case. Define the torque of a couple. It is the product of the force and perpendicular distance between the two forces. There are two forces, force A and B, 8 newtons each, 1.5 meter apart. What's the torque? So one of the force multiply by perpendicular distance, that means 8 times 1.5, which comes out to be 12 Newton meter. Now, they ask us whether the rod is in equilibrium or not. Remember that the weight is at the center. The pin must be acting in the opposite direction, applying a force in the opposite direction. That is your contact force. 8 newtons on the right hand side is downward, and 8 newtons on the left hand side is upwards. So if you observe, all the forces are equal and opposite, so they cancel out. In other words, resultant force is zero. But are they in equilibrium? They will be in equilibrium if resultant moment is also zero. In this case, the torque of the couple is creating the resultant moment. So we would say that resultant force due to the couple is zero. Weight is balanced by reaction. Resultant force is zero. But resultant moment is not zero due to the torque of the couple. Thus, the object is not in equilibrium. So it will start to rotate. Okay. Now they are hanging the object by two ropes, rope A and rope B. The weight of the rod is 2.4, and rope A is at 0.3 meters from the left, and the total length of the rod is 1.5. We have to find the tension in the rope B. Again, here we have a choice. You can take any point as pivot. For example, I take point P as pivot. The advantage will be that rope A will have no moment. So I take pivot at P. Weight will create clockwise movement. Rope B will create anti-clockwise movement. So total length is 1.5, and from the left end, the weight will be at 0.75 meters minus zero point 0.3, and we get the distance from the pivot as 0.45. For rope B, the distance will be 1.2 meters because 1.5 minus zero point 0.3 is 1.2. Now apply the principal moment, that is rope B into 1.2 is equal to 2.4 into 4.45. And from here, we get the value of force as 0.9. What is the rope? A has tension because both the forces, rope A and rope B, is upward. Downward force is 2.4. So adding them up should be equal to 2.4. FB is 0.9 and total force is 2.4. Subtract 0.9 from that and you get the value of force A as 1.5 Newton. So these are some of the questions. Tomorrow, inshallah, we'll be doing more questions from moment of force, and then we'll also start the questions from elasticity. I have posted both the worksheets